Happy Monday, everybody. How's it going?
So,
Good.
well,
Hey.
let's welcome our guests. Thanks for being here, David and Johnny.
Thanks for having
What's
us.
going on, guys?
Yeah, thanks.
Yeah. How's everybody's weekend?
Mine was good. I was in Europe, so I had
Oh,
a fun
okay.
time.
Oh, we're in
Yeah,
Europe.
Ibiza. Yeah,
Been there before?
it was a good time. A friend had a party out there, and I ended up getting invited pretty last minute and doing a pretty quick trip out there, only for like 3 days.
Oh, that's not a lot of time out there. But I'm glad you had a fun weekend there.
Yeah, it was fun.
How about you, Johnny?
Yeah, but it's funny. In some respects, Dave and my lives are so different. Where I had like a very domestic weekend, with like in the wind down of summer, like with the school year fast approaching and the kids. So it was much more sort of domestically tranquil, I suppose.
So no Ibiza for you. Okay.
No visa. Yeah.
Oh, that's awesome. How about you, Matt? Any fun things?
Just hanging out in New Jersey right now. So my nephew turned 18, so we just had a little birthday party out
It's
here.
like an adult.
Yeah, exactly. Gonna get real crazy.
You'll go to Ibiza.
Next week, yeah. Take it
Next week. That's awesome. Cool. I guess for people who don't know who you are, you want to give a quick intro.
Sure. Yeah, so I'm Dave Yaffe. I'm a founder of Estuary. Myself and Johnny, he'll give an intro too, but we've done a few different companies together. We were actually in the ad tech space before this, which is a really interesting space, only in that the data scale is very large and the latency requirements are low. So we ended up building a bunch of technology for that space, and have since then taken it and applied it to a bit of a more generalized fashion and built a company called Estuary, which is what we're doing now.
Yep. So hey, I'm Johnny. I'm Dave's partner in crime. So as he kind of mentioned, like we kind of spent a bunch of time cutting our teeth in ad tech, which as an engineer, whatever you're feeling on ads, maybe as an engineer, there's some fascinating problems in ads, which is why it was a kind of a fun place intellectually to hang out for a bit of for a bunch of years while we were working in that space. And yeah, we had some particular business problems that we can maybe get into, but we were trying to figure out how to solve them in that space, and it led us to building this streaming system called Gazette, totally open source, which we're now building on. And basically, we kind of like did a bit of a survey of the overall ecosystem when we were wrapping up that company and finishing what we were doing there, and trying to figure out, okay, what are people actually doing, and how are they using it, and sort of how can we help given the things that we've kind of learned and been doing. And that led more or less directly. I say directly, but it's always like a very zigzaggy road that leads you to anywhere in terms of any kind of thing you're building out. But we are trying to focus a little more high level on the problems of just like data synchronization. And I've got systems over here where data lives, and I've got systems over there, potentially multiple systems where I want that data to be, and I want it to be synchronized as quickly as possible and maybe transformed along the way. So that's the high level shape of the problem that we've been after for the last few years.
It's really cool. And I guess to level set with the audience, when we're talking about streaming data processing, what do you mean by streaming data processing? What is streaming data, first of all?
Yeah. I'll first kind of attack this head on, like to get at what is a bit of a misconception, because like for many in the audience, I'm sure you hear streaming data, the first thing you think is Kafka, but really what streaming data fundamentally is, and I'll explain it first in the context of like batch. So generally, if I'm doing like batch data movement, I'm taking this entire data set over here and I'm moving the entire data set over here. And I'm kind of doing that as a single operation. So when this data set changes, I'm just going to kind of fully refresh it and copy it over to where I want it to be. And that's generally a batch operation. So it's basically like it's typically kind of an all or nothing ordeal. Whereas streaming is really, it's more about sort of incrementality. It's like I've got changes of a data set over here, and I'm just moving the changes over to where I want it to be. And I keep on doing that. So you can use infrastructure like Kafka and Pulsar to implement streaming, but you can also use like Fivetran, which a lot of people think of as a batch company. actually, like if you're doing CDC, that is kind of streaming because they're just moving changes from a database to where you want it to be. If you're using like a DBT incremental model to incrementally update, sort of a model using DBT, like congratulations, that's kind of streaming. So it's a bit of a spectrum here where you can go, you can go whole hog into like using Kafka or something like that, but there are ways to implement a streaming data strategy on pretty much any kind of tooling or tech stack.
Yeah, I was just going to say, I mean, a lot of it is this mentality difference really between updating data in place versus insert-only schema. And each has its advantages and disadvantages. I mean, insert-only, the nice thing is you keep all this history. It's more of an event-based approach, but it's kind of tough sometimes for traditional data modelers to wrap their heads around it. But once they do, they can make a lot of progress using that approach.
Well, it's also sometimes tough for the infrastructure to scale with insert only too. So, but okay, so let's actually, I expect there'll be some pedantic discussions with the audience, maybe with us, but let's clear up some also streaming versus real time real quick, if you want to take a stab at that.
Yeah, even real time, there's a whole spectrum of real time streaming systems under the hood. A lot of the times they're leveraging things like micro batching, and they're not necessarily imposing large delays on transferring data, but there's some delays there, just for efficiency, for processing efficiency. Whereas when we talk about batch data processing, of course, those are just longer delays. But real time is kind of it's a flavor, right? It's something that means a lot of different things for different industries. If I'm in a hedge fund and I'm trying to do real-time trading is microseconds, right? That's not the same as anywhere else in the world where real-time trading is usually milliseconds. And it can be, for people in the loop, it can be seconds, right? A person can't really react to data that quickly. So it really is in the eye of the beholder and use case specific. But I'm curious what you guys think about that.
Well, it's an interesting spectrum. Yeah, I mean, what we see often is there's definitely, when people say real time, there's what you describe, which is basically as close to real time as you can get. And then it's interesting. Some people define it as like once a day or a week. I think we even heard once a month as real time. Matt, is that
yeah,
accurate?
I mean, if you think about it, say if you're in corporate America and you have a once a quarter reporting requirement, then suddenly once a week starts to feel pretty fast by comparison to that. On the other hand, if you need to monitor operational systems, then once a week or once a day or once an hour suddenly becomes very slow. And so, yeah, it really is a spectrum.
Mm-hmm. Yeah, and just say it's in the eye of the beholder. I don't know if there's I don't know. Anyway, moving on. So.
Yeah, but it would be nice to have a bit of a common definition where you could have a base of infrastructure that could then support multiple use cases. And when we talk about real time, for in the case of like our business, we're talking about that. We're not necessarily talking about hedge funds being able to do microsecond trading, but we're talking more about milliseconds in our use case at least.
Right.
Just it doesn't really roll off the tongue, which is part of the problem. But it's like if people would at least categorize, like, do I mean real time microseconds or milliseconds or seconds or minutes or hours or day, just like the order of magnitude, even that would sort of help facilitate the conversation.
Yeah, exactly. And Val has a comment here. Real time to him is the data that gets processed as it's generated. The frequency is dependent on the source. So yeah.
Potentially, I kind of call that continuous data. That's my own sort of taxonomy and nomenclature. That's continuous data, continuous processing, which doesn't really say anything about like the latency involved in that continuous data. So you can still have continuous data that's updated every 15 minutes, if you're using Fivetran or something like that.
Yeah, we've seen this whole new phenomenon too in a variety of tools, what I call dynamic batching, which is you get away from the fixed batching of traditional batch like data warehousing and such, and you just like wait for data to accumulate, and then you run a batch as soon as it makes sense to do so. And that can be like every minute, can be every 5 minutes. And you just need to stipulate like, what are my latency requirements, and make sure those are met for the application in question.
Yeah. Another strategy that we've kind of employed is dependent on the downstream system that you're pushing to, right? Some downstream systems take a while to commit transactions. So you can't push to it more than once every so often. So that's a kind of a strategy where we'll bulk up some updates and then push all those updates at the same time in the next transaction.
We found that we quite like that ourselves. It's what we do, and it's basically using the back pressure of the place you're trying to move data to. Like you can only run a Snowflake transaction every so often. It's going to take a while for that transaction to commit, and you might as well be figuring out what the next transaction is going to be while the one that's committing is committing, and then as soon as it's done, you can just slurp that data over. So that ends up scaling pretty well between like the Snowflakes of the world, where you're talking like tens of minutes sometimes for a transaction to commit, versus like a DynamoDB where it's milliseconds.
Right. I would say there's definitely some anti-patterns that, Matt and I've seen with Snowflake inserts, for example. Like if you're moving data, use the copy command. Don't just do direct inserts. I think we've seen people try and do direct single row inserts to the Snowflake and just carpet bomb it to death, and then they're surprised their bill is really high for some reason.
And they'll get, it's supposed to be real time. That's the motivation for doing this, and yet it will fall like a week behind. It's just completely insane. We see it over and over again. It's all an engineering question, right? I saw some post the other day that was saying all of engineering is about managing trade-offs. It's true. It's like, what are your trade-offs in this system, and what do you actually need to accomplish, and make sure you're working towards those.
Yeah, for sure.
Yeah.
Actually, got a comment here or a question from Mike Nash. Speaking of trade-offs and speaking of cool people, he's interested to understand the decision between speed versus the quality and streaming, and if there is a trade-off.
That's a very good question. I think Johnny will be good at answering this, but very, very high level, there shouldn't be, right? There shouldn't be a trade-off of speed versus quality. A lot of the systems that we're using classically for streaming, they impose some of those trade-offs on you, but there's tools that I think we can kind of add to the landscape and the lingo of streaming that will help. Johnny, do you want to expand on that?
Yeah, I'm honestly, I'm still a little bit kind of parsing what quality means in this context. I'm not sure I fully create
data quality. I was thinking, data quality, making sure that your data is conforming to your schema, making sure that you're catching.
Okay, so I forgive you, Mike. Sorry, Mike. Hopefully that's what you actually meant by quality, but I think we'll kind of run with the interpretation that you mean sort of data quality. Yeah, I don't think they're. This is my opinion here. I'll get on my soapbox for a moment, but I feel like data quality is just kind of table stakes first for any kind of data processing system. Like if you're not processing data correctly, why process it at all? If you don't have trust that like the data movement and the end sort of data product that you're building is actually correct and fully meets all of your expectations in terms of what the pipeline is doing, then what is the pipeline even doing for you? So if you can't achieve data quality, like data quality comes first, and then you figure out how to make it fast, basically is what I'm saying.
But batch provides this kind of natural buffer where you land data and then you're given time to correct the data, right? And that's probably the type of thing that he's referring to here.
Yeah. What we've found is there are kind of like a couple of different operating modes of schema where sometimes like the data producer really kind of comes down to, do you control the data producer or do you not? So like, because you're either sort of like you're deeply in control of the data producer, and if there is a data quality issue, you can go fix it, or you don't control the data producer and you basically have to take what they give you and figure it out later. And both of those patterns are, super common and unavoidable in reality. So at some level, I think that the problem is sort of framing like, how do you tackle those two kinds of scenarios where if there's a data quality issue, you're fixing the sender versus a data quality issue where you're sort of dealing with it on the processing side. And it does require perhaps somewhat different strategies in streaming. We have a particular thing we've done. I think it's arguable whether we quite nailed it exactly right. Like we think it makes sense and is pretty good, but basically the idea is like separate the schemas, have a write time schema and have a read time schema. So have a schema that you're evaluating on write, and you can use that schema to basically reject records and use that as an indication that you need to go fix the data source, fix the data sender, or you can have like a really permissive schema that basically accepts nearly anything, or only sort of the most fundamental data contracts that you have for what you want that data to look like. And once that write schema has passed, is validated, then your record is going to be added to the stream, and you are now turning this into a sort of a downstream processing problem if there are data quality issues, where you have a separate read schema, which can be much more exacting in terms of the data contracts and constraints that you're evaluating. And basically it just means, if that schema breaks, it's your problem to go fix the transformation or the destination or wherever you're moving that data to. So it allows for sort of threading this needle of like, am I pushing this problem back onto the sender, or I'm going to deal with it on the consuming side?
And is this what you would call ETLT? I know we kind of talked about that in some of our pre-show notes, and I think the idea of that is you're combining elements of basically transform on initial ingestion and then transform on final read.
I think it's a core ingredient to doing ETLT well. ETLT is like, I'd sort of categorize it as a layer on top of this, where if I have so just to unpack the terms, like ETLT, what that really is saying is transform wherever it makes sense. Like sometimes it makes sense to transform data in the data warehouse. Great, do that. Sometimes it makes sense to roll up data or do some filtering or a join or something before you put that data into the data warehouse. And that can lead to dramatic cost efficiencies, for example, or dramatic reductions in latency when you do that well. So ETLT is basically just saying, like, transform where it makes sense. Sometimes it really makes sense to transform the data in motion. Sometimes it makes sense to do it in the warehouse. But if you're doing any kind of transformation and the data that you're transforming over is not meeting the data contract that you expect it to have, then you've got to fix it, whether that's happening in a transformation in the warehouse or it's happening in a transformation that's being applied as the data is being processed. So it's not that, this read schema, write schema dichotomy, it's not like exactly ETLT, but it's what gives you some assurance that the transformation that you're applying in flight is actually doing what you think it is. Because if you're transforming data you don't understand, or that doesn't meet your data contract, like it's a worthless transformation.
Yeah, and a nice thing to do in that little t, the first T in ETLT would be to make sure that your data quality that you're landing downstream is what you want, right? That's something that is obviously much better to do earlier in a process, so that all of your consumers are seeing high quality data versus not doing that.
Well, I mean, the interesting, this term really resonated with me because in practice, I think most organizations are doing some version of ETLT. Rarely do you see pure ETL or pure ELT. Like generally there's some kind of checking that happens up front and then some kind of post transformation later on as you maybe change the schema and such and remodel the data. I don't know. What are your thoughts on this, Joe?
I think as we were joking maybe a couple of years ago, I was on a hike and I don't know, as usually happens, I have really stupid thoughts, and one of them was just ETLs, like the inevitability of all this. Doesn't matter what happens, it's you transform and load it at some point. I think what Johnny was saying was absolutely correct, though. It rewind about 7 minutes back or something like that. It was at the end of the day, the data quality is really what matters, and so what are your expectations of the data? I think get that right first. Ideally, that should be, I mean, if you're looking at the root cause analysis of it, ideally that should be handled by the upstream producer as much as possible. But sometimes, especially if you're dealing with third parties, that's not going to be realistic unless you have a good relationship with them and can change that. So just know what to expect up front. Because the thing is, once you turn on the fire hose of data, not AWS fire hose, but just the fire hose of streaming data, for example, this can get very expensive for you. So get it right. Before you turn on the spigot. So those are my thoughts on it. But yeah, actually, there's a good, I think, kind of related question here from Rohit. Yes, how do real-time streaming applications handle schema evolution, and what's the best data format for storage for real-time use cases?
Yeah, I I'm actually going to tackle the second part of that question first, because it leads to the first part of the question.
Sure.
I have a somewhat controversial take. I think the best format is JSON. And
Ooh, spicy.
Yeah, it's my spicy take for a few reasons. And just to knock like some of the immediate objections off, like JSON parsing slow, not really. Like you can parse JSON at the speed of memory. It is not slow with a really well optimized implementation. And if you just avoid parsing it over and over again, it's really not a problem. JSON also is, it's basically like the language of the internet. It's the language of APIs. So one of the nice aspects of JSON is that we do a bunch of integrations and work with like SaaS data providers where we're basically just pulling down API responses. So if you want to arbitrarily be able to represent any data that you might actually need to deal with on the internet, like JSON is pretty much the one and only format to do that really well. If you're needing to deal with things like unions where sometimes a location in a document can be like an object and sometimes it's an array, like JSON can represent that and nothing else really can well. But you have to have schema. I mean, we just had a whole conversation about data quality, and one of the primary complaints about JSON is the anything goes nature of JSON, which is certainly true. But like an individual JSON document tells you nothing about the structure of that data. So there's this thing called JSON schema. This is an open standard. It's now part of Open API as well, the Open API specification, but it's basically a way of structuring and representing like both the syntax and also some of the semantics, like validations of data of JSON. So that's the road we've gone down. We're kind of all in on JSON schema. In many respects, it's kind of an implementation detail of what we do, but it's like a really fundamental one. So the particular answer, getting to the first part of this question of like, how do you handle schema evolution? I can answer this in terms of what it means to us and what we do, which is representing our best understanding of how to solve this problem, which is like, you have to have a schema, and in our case, it's JSON schema. You have to validate it every single time you're looking at a document, whether you're writing that document or reading that document. And if there is a change in that schema, then you need to pause the pipeline to figure out what to do about it. So that can mean automating a change to a downstream like table definition, because you're going to add some new columns. Like basically, like you see a document that has some additional data in it. You pause the pipeline because you weren't expecting that data, and then you're using kind of a higher level coordinator to go update like a downstream table definition so that the pipeline can continue. So it doesn't mean necessarily that a human needs to be in the loop every time, but you can also have cases where I've got a transformation that I'm running on data as it's in flight, and the schema of my data has changed. Something that I was expecting to always be an integer is now a floating point, for example. And I better pause the pipeline, because if I let my transformation continue, I might spit out bad data, like, apply a transformation where it doesn't actually semantically understand what it is that it's transforming over. And in that case, it's better to pause the pipeline so that I can go update it, fix it, and then re-enable it and have it continue from there, now that I have this updated understanding of what this data is supposed to actually be. So yeah, TLDR, basically JSON, and use some kind of schema validation and validate everywhere on read and write, to make sure that you can kind of pause these components before you're allowing bad data to propagate downstream.
And so it sounds like to some extent you're talking about a replay approach to schema evolution. In other words, have some kind of data contract or schema enforcement in your pipeline, but then keep all the data even if it doesn't comply, so you can replay to pick up the new changes as needed.
Yes.
You can make a decision. Okay.
Yeah.
Exactly.
That's part of the advantage of separating like write time schema and read time schema, is your write time producers, as long as they're passing the write time schema, they can keep on doing what they're doing. They can keep on capturing data. You're not losing anything. And then you update your read time schema, your read time understanding of the transformation that you're doing, to basically unblock it and get it to continue if there's an upstream data change.
Got it. Are you setting those rejections like a dead letter queue, or are you just letting those accumulate in the body of the data that's being ingested?
Yeah, and just to unpack that, a dead letter queue is another approach that's commonly used, where it's like I have some records coming in that don't match my schema, and rather than allowing them to be processed, I kind of shunt them to another queue that's representing what's called like a dead letter queue. So it's basically just like a buffer of stuff that doesn't actually match my expectation. Again, my opinion, but I think dead letter queues are a hack and not even a particularly good one at that. It's basically just a way of like keeping a pipeline going in exchange for lowering the data quality, which, you know, as we've said earlier in this conversation, like you have to start with data quality. So a dead letter queue, basically, if like I have documents that don't match my expectation and I shunt them into that dead letter queue, it basically means that like my transformation is no longer doing what I thought it was. You know, de facto, it's like if I'm not processing some of the input data, then what exactly am I getting on the other side of this transformation? So again, opinion, but no, I don't mean dead letter queues. I mean, if I have a downstream process that's like moving data somewhere or transforming it, pause it, stop it in its tracks, you know, immediately before it processes a document that it doesn't understand, so that you have an opportunity to fix it and update the understanding of what that transformation should be doing, and then re-enable it to have it continue right from that very first document that that does not validate against the schema it had.
Got it.
That said, a dead letter queue is something that we've gotten asked for, of course, and it is something that, you know, we do support. So we can't be totally philosophical all the time.
Well, it seems like it's kind of a pragmatic approach if you know that once in a while you're just going to get bad documents coming in and there's nothing you can do about that. And so then you can check your dead letter queue and say, okay, is this just a bad piece of data that I can't process, or is this a schema change and I need to go back and fix everything from there?
Yeah, I think Johnny's approach reminds me a lot of in Toyota's lean practices, for example. It's one of the things they came up with is the add-on cord, right? So in the production line, if something fails, anyone can pull the cord and it stops the production line completely until that error is resolved, and then you can move on. Because the whole idea is if you can catch a defect right as it happens, you've actually saved a ton of rework, because rework is a form of waste, right? So the dead letter queue would be a form of rework where you're batching up things that you potentially will eventually get back to at some point. But yeah, I think there's probably a time and place for both. You know, if you know, for example, that like, yeah, it's an interesting one. So I feel like I guess it's a question of what you can really do about it at the end of the day, right? Because if you're getting data from a third party, it's like, I don't know. So
yeah,
hopefully
so
they
practically
just fix it and don't have a problem. Yeah.
Practically speaking, you know, what we've seen is that if you take that heavy-handed approach, it does save time after a while, right? After you take the effort to update your transformation and fix the small things that you didn't anticipate within your initial transformation. Because most of the time we're talking about normalization. We're not talking about, you know, anything else. It's normalization that you can do in a pipeline that you didn't expect that you would have to do. So, you know, in general, we do think, you know, we do see that these are things that you can address. You just haven't anticipated them up front.
Sure. Actually, Rob has a question here. So when you want to recover, do you continue to replace Restream, or are there cases where you should be able to switch to batch mode for recovery, changing downstream data, like in a data warehouse, and adding a new target more efficiently?
Mm-hmm. Yeah. My answer hinges a little bit on like what it means to restream. The answer is restreaming, basically, sort of continuing. But whether I think this question's kind of getting at like, are you using this? I feel like this question is tied a little bit to infrastructure, so I'm answering the question in that context. Because in this context, I think restream means like, are you pulling from a Kafka topic? Are you continuing to pull from a Kafka topic? Are you switching over to a batch technique to go refresh this data? And you know, part of the challenge here, again, like getting at the infrastructure a little bit, is if you've got, these decoupled like producers of data where, that producer of data, like you had a pipeline pause, and maybe it takes you a couple of days to actually get back around to fixing this problem. And meanwhile, your data producer has just been going nuts, writing a ton of additional data. So you can legitimately get into situations where there's quite a bit of data now queued up that you need to actually process and restream. So there can be sort of operational challenges with some streaming systems around like, well, if I've got a Kafka cluster, for example, I don't, and that Kafka cluster is handling all of my real-time writes that are coming into my system, I don't necessarily want to, or I want to minimize the amount of time that I'm like asking it to give me as much data as it can, as quickly as it can. There's a bit of a tension there where that Kafka cluster is like, I'm asking it to simultaneously be this like real-time written record of changes that are happening in my system, and to also be this really high throughput, high scale batch system, or like high throughput, high scale system to pull as much data as quickly as possible. And there's a fundamental tension there because I'm asking literally the very same like broker disks to be taking real-time writes and also to be slurping as much data over to me as quickly as possible. So I think that's some of the tension that question's getting at. I could be reading a lot into the tea leaves here, but that honestly, that gets into, we don't use Kafka, and we could talk about why, because
yeah, let's talk about that. Why don't you use Kafka? And what do you use instead?
Yeah, so as a bit of background, as Dave and I mentioned, we spent a bunch of time in ad tech, and a previous company that we built, we were dealing with a lot of data that was coming in very quickly, very large volumes of data, hundreds of thousands of events per second. And we needed to kind of take this data in and stitch it together in various ways and then get it back out the door. And the nature of that business meant that the faster that we did that, the better we did. Basically, like latency in that business and that application was really important. The overall end-to-end latency of like data in and data out. Kafka, this was like 2014. This is a bunch of years ago, but much of this has not really changed in that time. At the time, especially, Kafka was fundamentally limited to the disk storage that you had available on your brokers. You could not have more data in your Kafka topic than you could fit onto your broker's disks. And as a small startup, this was terrifying. Like we were building our entire sort of application on this notion of like everything is essentially continuously processed. So the major beef at the time with Kafka, the reason for not using it was this tension of like, we have these broker disks, they're a fixed resource. If we fill them up, we're kind of screwed. And we also want to be able to stand up new downstream applications where we're reading like a ton of data as quickly as possible. And having that all go through these broker disks seems like a really bad idea, where we also want those broker disks to be supporting our production write load. So the thing we wanted instead was like, we've got cloud storage. Cloud storage is great. And particularly on the read side, cloud storage allows for like really, really elastic resource utilization. Like you can get a lot of IOPS, like reading data from S3, and you can do that in parallel. And if you can figure out ways to read from like have writes go into a system that's sort of accepting them, committing them, making sure they're not lost, and then have the bulk of your historical reads actually be served directly from cloud storage, then that's kind of like the best place to be operationally. So we ended up building a system called Gazette, which is still what we use today. It's totally open source. Gazette.dev is the website for it. But the fundamental thing that it does really well is it is accepting those writes. It's committing them, replicating them, making sure that they're not lost. But then basically, as soon as those writes have settled a bit, it's getting it into cloud storage, and all the reads of data happen from cloud storage. So the write path goes through these Gazette brokers, and then the read path, these brokers are essentially laying all this data out into cloud storage, and basically like you can consider a real-time data lake. And then readers are, as much as possible, pulling content directly from cloud storage until they catch up to the really, really recent stuff. And then it's streamed with millisecond latency from the brokers. So it gives you this way of threading, like, I can have a topic of data, which is unbounded in size, however much data I want to store in cloud storage. And I can go and reprocess all that historical data. And it's a really cheap and efficient operation. And I'm not going to knock over my production infrastructure when I do it. And also get the benefits of millisecond latency streaming, because once I've finished with all of that historical data, I'm getting it sent directly to me as it happens from the brokers.
That's an interesting approach.
Yeah, and I know that to some extent Kafka has added this capability over time. I don't know how finicky it is, but they've added like push down to cloud storage and stuff. But yeah, this is always the tension with streaming, right? Because there's always the need to go back in history where you really don't want to deal with one event at a time. You want to process an entire month's worth of data, for example. Yeah, that's fantastic. I mean, what do you see as the ongoing
I will
evolution?
point out just that
go for it.
Kafka has implemented this feature called segment offload, which basically does that. It's a way of having the Kafka brokers move some of the topic into cloud storage, but you still have a problem when you're actually reading this data. You're still needing to go through the Kafka brokers to do it. Mm-hmm. You're not able to go directly read files from cloud storage, which is really the optimum, and that's really what you want. To be able to have the reader of data just go directly and talk to S3 to fetch that data rather than proxying it through your production Kafka brokers.
Because then you're taking advantage of all the performance characteristics of S3, which is exactly what you're talking about.
Yeah.
Do you have best practice? I know that partitioning can be a bit of a hassle with S3 if you don't know what you're doing, and you can get hot spotting. Do you guys address that issue as well, like proper partitioning of
and
so forth?
So at a high level, use multiple files. So the way that Gazette happens to do this is basically sort of opportunistically letting data build up so that you have files that are, half a gigabyte or a gigabyte in size, something that's like a nice chunky size to work with from S3. S3 and all the cloud storage providers are like this. The setup time to like start a read is slow. And then once you have data being sent to you, it's fast. You get a lot of data sent to you very quickly. So you really don't want lots of small files. You want a healthy number of you want like nice sized files. So the high level strategy is just, I can speak to how Gazette solves this problem, which is basically, it's got like a when you write data, it's not immediately going to cloud storage. It's basically replicated across brokers, across availability zones. And then those brokers will decide to periodically persist it into cloud storage. And, once that happens, it starts being served directly from cloud storage. But the primary thing that buys you is it gives you a nice layout of like well-sized files so that you're not dealing with like tons of tiny, kilobyte files, which is basically an anti-pattern for using cloud storage well.
And how do you manage metadata? Say I want to run a historic query. Do I end up like hitting Gazette and then it tells me where to access that data in S3, for example?
That's exactly right. So cloud storage providers have this really neat feature of signed URLs, where basically like you can, as a data owner, within S3, I can create this URL that gives you, Matt, a capability to go read a particular file from S3. And it's like a time limited thing. And, but what's really neat about this is the brokers, you can basically maintain an index of what all the data is in cloud storage, and then just hand people signed URLs to go directly read data as they need it.
Pretty cool. Let's see. Got a comment here from Jonathan. Maybe you can speak to this. He says, because that sounds like it leverages blob storage in a similar manner to Spark Delta tables. Any comments on that?
Yeah, presumably. I'll be honest. I'm not that knowledgeable about Spark Delta tables or exactly how they're implemented.
Got it.
We're a little bit crazy in that we've been living in this other ecosystem for a bunch of time now. So I can't speak authoritatively to exactly how Spark Delta tables are working.
Cool. I guess kind of switching gears a bit, it feels like, I think from Matt and I's perspective, and we wrote about this in the last chapter of our book, but the modern data stack, that's been around for a while now. I'm guessing maybe 11 years, depending on how you want to judge it. I dated as to when Redshift came on the scene, cloud data warehousing and so forth. And what that did, it really democratized data warehousing to the masses, right? And then you had tools like Fivetran that came along, and I think helped democratize data pipelines to the masses as well, dbt and so forth. But it feels like, in my opinion, I'd love your take on this. It feels like that ship's gone. I'm tired of talking about the modern data stack in a lot of ways. I think it is what it is, but it's rehashing a lot of stuff that we've been talking about for a long time. But I feel like what's next is really what Matt and I call in our book the live data stack, and this is a democratization of streaming to the masses in much the same way that ease of use is brought with the modern data stack over 10 years ago. Do you have any thoughts on this notion? Are we?
That sounds like you're describing exactly why we built the company that we built, Estuary. So at a really high level, our initial thought was it's just way too hard to work with streaming data. It involves multiple pieces, right? The biggest one is that usually sources don't provide data in a streaming fashion. So you kind of need to figure out how to extract it out of those systems. So that could be CDC, right? Using change data capture. It could also just be real-time API endpoints. Some APIs actually provide those, or just extracting with as low latency as you possibly can, right? And in some cases, you can't get a real-time endpoint. So, that's one piece of the puzzle. You have transformations, which in streaming systems tend to be difficult. And they have to deal with stuff like state, which, state in a streaming system is not something that is easy to work with. You're imposed, windowing is imposed on you and other things like that just aren't artifacts of batch systems and kind of are unique in the streaming world. And then, of course, getting data into the systems that you actually care about, whether you're doing analytics and you're pushing to a warehouse, or you're doing something more operational and you're pushing to maybe a key value store or something like that. So that whole shape of that problem is really what we have identified as the next stage of this landscape. And I love your terminology, the live data stack.
Yeah,
that might
great.
be something that we'll have to start stealing.
Steal it, but go ahead.
Yeah.
And I'll just mention the big idea for us behind the live data stack wasn't just streaming, but it was also this idea that you would almost put a streaming layer right on top of an application. And so as the application is making commits, those can go immediately into an analytics layer. And from our perspective, the big blocker for that in the past was just complexity, right? Going back to the discussion around Kafka, like Kafka used to be really hard to implement. So if you wanted to do this 5-10 years ago, it was huge pain with a lot of operational overhead. Mm-hmm. And now it's getting way easier with all kinds of great tools out there.
Yeah, there's a connection with like the data mesh concept out of ThoughtWorks as well, where traditionally data mesh is understood to apply a little bit more precisely to like analytical use cases, but I really think it's just as applicable to operational use cases. But there's streaming has had a democratization problem for a long time, where basically the only people, the cabal of people who are able to actually use streaming effectively are like these, very highly skilled engineers who know these systems well and are able to operate and support them. But you have like a wide spectrum of other data users within an organization who might find that data valuable, who, an application just, because that's the way the application authors built it, it's throwing off logs, events, records of what it's doing into Kafka topics. Well, there are lots of other uses of that data within the organization. And there are people who might not be as technical, who are not ready to go stand up a Kafka consumer, who might want to actually leverage that data. So they're a little bit like the data mesh concept kind of like evolved in parallel to how we've been thinking about it, to be honest. But there's it really resonated with us because like part of the mission that we have is basically enabling a lot of those less technical users to really leverage streaming, fundamentally streaming infrastructure in order to solve business problems around the data that they have without needing to like bring in new expert backend developers to go build a Kafka consumer.
Yeah, the primary problem with streaming is cost from a business perspective, right? And for the most part, in the past, it hasn't been worth it because the business use cases haven't necessarily warranted the cost, and that that cost is not necessarily a technology cost; it's actually a people cost, right? It's the people that understand and can work with those systems. So that's the real problem. And I think we're kind of on an inflection curve where we're getting to the point where those two things are going to start overlapping.
Yeah, I feel like Kinesis on AWS was a big step in this direction. And then also a lot of the stuff that Confluent has done to make Kafka more accessible, and then a variety of companies.
Well, the GCP Pub Sub, I mean, dear God, that thing is like almost too easy to use.
Yeah.
Yeah.
Mm-hmm. Yeah, exactly.
Yeah, and it's interesting. Rob Oak's got a good comment here. When latency approaches real time, the difference between analytics and operations starts to disappear. Stream starts to use, for both in part because you kind of, and this is, I think, the notion of the live data stack that we touch on too, is that feedback loop between application and analytics, machine learning, it tightens, it shortens, and at some point, I would say these are almost false divisions, especially as you bring up data mesh, for example, right? And the whole notion is data product development. And we have these artificial distinctions, which I think are still very much in play, but I think are not doing us any favors to keep them lingering, right? So the distinction, the dichotomy between, say, quote, data and applications, for example. Any more applications, I think the expectation is they're going to be data powered, quote unquote. There shouldn't be any distinction between these. I actually wrote a blog post about this over the weekend, the divide between data and dev. I did 2 meetups last week, one in Salt Lake City, speaking to a bunch of software engineering managers and individual contributors and so forth. And a couple of days later, went to Atlanta, talked to a bunch of data engineers, and the common theme was data doesn't talk to dev, right, and vice versa. But I think with a forcing function is going to be the tooling that we have. I think in a batch-oriented world, for example, it's much easier to pass the buck. Dev can just say, well, here's your data, F off and have a nice day. With streaming, that feedback loop tightens to the point where you have I would say, tighter coupling between teams, which sort of contradicts the whole data mesh concept because it's supposed to decouple. But I think if you have a tighter feedback loop, you resolve issues much more quickly.
Yeah.
Because if you don't, then it doesn't work.
And I think it all comes back to data contracts too. I'm chuckling a little bit because the pass the buck mentality is epitomized by like Fivetran, where it's basically like any problem the data consumer becomes the downstream consumer's job to fix, whether they want to be or not. So it's like I don't think that works in a real-time context or streaming context at all, because honestly, it doesn't work in a batch context either. But it's just kind of what a lot of people are used to. So
let's do tech debt, data debt, right? That just is pushed downstream, and over time can accumulate quite a bit.
Yeah, but I think it only works, like the data mesh concept only works with contracts. It's like the data producer, the team that's like has the application that's producing data, they might not need to be like directly coordinating with another team that wants to use it, but they had better have a contract of what their data is and looks like and means that other team can reference.
Right. Good questions here. Andy asks, do you think we can achieve a live warehouse, maybe star schema like with complex transformations, e.g. not just using views, due to being expensive, having high latency? What are your thoughts on this?
Yeah. Kind of, yes. I think we're getting there. And this is not like a journey that's over at all, but there are a few companies I'll throw out that, so starting with Druid has this cool thing where essentially you can express a schema within Druid where you're effectively layering in like aggregations that you want to happen to your data. And Druid will kind of do this continuously, rolling up certain metrics by summing them together, for example. Materialize, the company as well, has done a lot of really interesting work in this respect as well. So Materialize, for those who don't know, they are streaming compute, streaming transformation expressed to SQL. So write a SQL query that gets where effectively they're figuring out how to aggregate this data and turn it into views based on sort of incremental updates that are kind of flowing into the system. And we have a thing as well, which is we basically allow you to express, like, if you have multiple documents, basically the term of art is called a reduction. If I've got two different records for a given key, I need to figure out how to smush those records together in the most sensible way. And very often, if I've got like a fact table, that can mean that I've got like some dimensions, which are kind of like the key of my record, and then some metrics, which might be things like sums or hyperlog logs or whatever. You can also imagine much sort of deeper ones where I'm like merging things together. So it is achievable, basically, and it is a little more technically challenging today than I would like it to be. And this is a place where I think as an industry, we're kind of working towards really compelling and interesting solutions to be able to do this. But fundamentally, you have to teach the technical system how to take these multiple like changes that are happening to a view and incrementally update that view. And if we do that well as an industry, then I think we can nail this problem.
Oh yeah, and joins I think were a big one for Druid. I remember hanging out with Gian Merlino a couple years ago when he was giving a talk on my meetup, and we were driving around. He was still trying to figure out the join issue with Druid at the time, because it's a non-trivial thing. Real-time joins in analytical database is like not easy. I think we're talking like roaring bitmaps and stuff like that. Getting very, very granular. Because you have to at that point. It's just, I mean, how do you deal with high throughput but do it in a way that has low latency, right? Because people expect the lab to have low latency. So stuff like star schemas, I think it's totally doable, but it does depend on you have to solve the join problem too, which is it's you got a lot of smart people working on this, and it ain't easy. So
and that's the fundamental kind of nature of the problem. Like if you're doing a join and you're doing this in a streaming fashion, it requires that you keep a bunch of inner state around to affect that join. If I've got like an example I'll go to is like products and orders. I've got like a product catalog and I've got orders of like products that are being ordered, and I want to enrich those orders with information from my product catalog. Well, one way or another, it basically requires that you keep that product catalog or some element of it around so that when an order comes in, you can join it and send it on its way. So all of these technologies that we're talking about, they're doing some kind of that, some kind of like keeping that inner state around in order to affect join. So there are interesting trade-offs in terms of like, are you trying to make a really simple to use system that is kind of hiding some of those aspects of that inner state, or are you kind of like surfacing and elevating the inherent domain complexity of that inner state and making it a little bit more accessible to the user? And I think there's a bunch of interesting work happening in parallel on this problem.
If you kind of zoom out like 5 years from now, like where do you think the whole streaming space is going?
Yeah, we'll probably have slightly different answers there, but I think to me, it's going to basically be taking over a little bit more of, especially the real use cases, right? A lot of real use cases that could have value from streaming data are not employing streaming data today. Those are things like customer 360. If you want to have a customer in the loop type of situation, you really want to have all the information about that customer that you have. If you have a support person who is talking to a customer, they should have everything that has happened with that user in the past, and understand that they had a ticket last week and they were also on your website potentially looking at this product the other day. That would be a really nice way to empower maybe a salesperson. But that's not the case because it's kind of difficult for the most part. It's getting to be more the case over time, right? We're getting specific tools that are built to accomplish that, but I think we're going to be able to do it in a little bit more general format and empower people to do that themselves. So, those use cases that we see that really require streaming are in customer 360, marketing, finance, a bunch of industries like that, telecom, and we're seeing that now where those larger companies have the money to employ their people that can actually handle this problem. But as it becomes more accessible, we're just opening up more and more specific use cases. that maybe didn't have the exact same type of necessity, security, right? We all needed Splunk to have access to real-time access to logs. That was something that you needed a tool to do, and I think that's changing over time, right? Like you're now able to get some of your logs potentially into your data warehouse and query them live in your data warehouse using some technologies. So that's my answer, at least.
Yes.
What about you, Johnny?
I think we're heading towards convergence, and I hope that eventually we can stop having these industry debates between batch and streaming.
Yeah.
It's just not an interesting thing to talk about anymore.
Mm-hmm.
And kinds of, we mentioned modern data stack. The modern data stack is still very much here. It's just less interesting to talk about because we're all doing it or some aspect of it. And for batch versus streaming, you have sort of batch infrastructure providers like Snowflake, for one, getting more into lower latency updating and building capabilities that are traditionally streaming. And at the same time, you have streaming technology providers trying to figure out how to work really well with batch systems. So I think we're just heading towards sort of general convergence. And as Dave says, it's like the companies have dedicated like streaming resources under this historical notion that streaming is more expensive, especially from a people cost, to like the top one, the top two, maybe the top three problems that they have. But there's like a litany of other problems that could also benefit from it as well. At the end of the day, nobody wants slower data. Like if you can have fast data cheaply, of course you want that. So I think we're just going to see more usage, more applications of this, a lowering of the learning curve to actually employ these techniques well, and convergence from infrastructure providers where like everyone's kind of doing both over time.
So in terms of business use cases, I mean, obviously you guys came from this ad tech background. That was a pretty compelling use case for real-time data. If I'm a business and I'm interested in expanding my real-time data practice, where else should I look? Like, what are some interesting use cases for a typical business that are really going to help the business to function better?
Yeah, so we see the delineation being a lot around the specific type of business a lot of the time, right? So we will work with a lot of telecom or finance, or we see use cases in like aviation and use cases in marketing for sure. But almost every business has some sort of marketing use case, and that's the real one that we kind of see a decent amount of the time, especially since some marketing APIs make data available in real time. So like Salesforce, for instance, has a real-time API, and you can actually start to do stuff. You can action off of customer behavior using that real-time API. So that's something that is really, really common to kind of be an entry point. But there's other things too that you don't think about where real-time helps you with that. Streaming helps you specifically with like things like SOC compliance, right? If you want to have a change log of every event that's happened within your business, you need to work with event-based data, right? That's the only real way to do it. And if you're working with, for instance, batch CDC and trying to have a record of every single change that's happened, you just won't be able to get there. You need to have log-based CDC to solve that problem. So those are just some random examples.
Either like I think use cases that often come from people who aren't approaching it as like, oh, I need streaming for this. It's really more like a synchronization problem. So like one specific one we see all the time is basically like I've got an operational database, and I want to enable these features like search, or maybe even plug it into like a vector database so I can do run it through ChatGPT or something like that. Or get embeddings for stuff that's in my production database. So it's basically like I've got a database over here, and I've got these other things I want to do with this data. And I don't care if it's batch or streaming. I basically just want these other systems to have up-to-date views of my data so that I can, use it for search or, like use it for these different applications. As a bit of a tangent, I think it all kind of comes back to search, because if you look at like what a lot of people are doing with ChatGPT and vector databases and embeddings and whatnot, it's basically just a semantic search. It's like another way of approaching what you might use Elasticsearch for. But that kind of connectivity between like different bespoke tools for working with my data that do really neat things and just having them all interoperate together, like that's another use case that we typically see where no one's coming in saying like, I need streaming for this. It's basically just, I want data synchronization between these different places where my data is held.
Interesting. You probably wouldn't know what to call it, actually. You know, it's not that, like you say, oh, I need streaming, right? I mean, it's like I think you point out a good thing. It's how you talk about it too. Think of data synchronization versus just some buzzword that we happen to use in our kind of data bubble here, right? So most users are just like, yeah, I just need data to write quickly. That's all. So it's really cool.
Yep, exactly.
Yeah, awesome. Well, it's been a fun chat. I think a lot of people liked it. I'd like to think so, at least. So lots of good comments in the chat here. So for people who want to learn more about you guys and what you're up to at Estuary, how can they do that?
Yeah, so come to our website. That's estuary.dev, and reach out. We have a few ways to reach out on the website. So yeah, we'd love to hear from you. You can also email us directly. I'm Dave at estuary.dev.
Thanks. Cool. Any fun events coming up for anybody?
That's a good question. Yeah, I mean, I've been joining just the New York-based happy hours, the Lookie stuff that Ethan has been having, but no, we don't have too much. Maybe Johnny will join you in your Chicago event that you're holding next week.
October, yeah.
October. Yeah. What is the Loki thing is on Wednesday, I think, this time?
Yep.
Yeah, I think it is on Wednesday, so on my calendar. Yeah, I won't be there. Matt will be there. Maybe.
Yeah, that's the plan.
Maybe David will be there too. On Wednesday, I'll be speaking at the Utah Data Engineering Meetup. It's like the band that plays at its own club. So I'm going to show up and give a talk there. And I think that'll be the last time I give a talk in Utah for quite a while. Later this week, I'm going to be off to Australia for a 2-week tour for Data Eng Bites. So if you happen to be in Australia, in Perth, Brisbane, Melbourne, Sydney, come say hi. Glad to meet everybody. So yeah, should be a lot of fun. But yeah, thanks everybody in the audience. Great chat, really good questions, and we have so next week will be actually a pre-recorded episode of Monday Morning Data Chat because I'll be in Australia and it's going to be kind of hellish to record live. So it's gonna be a lot of fun. I think what was it, Holland Nelson we have on the show, Matt? So
yeah, we'll be actually chatting with her this afternoon and then broadcast it on Monday. So yeah.
Yep, exactly.
So she wrote what is it, Essential Math for AI for O'Reilly, and she's got another book in flight as well. And so if those are interesting topics for you, AI or math, definitely join in next week.
Yeah, it'd be kind of fun chat because we're all a bunch of math nerds. I think you two are bigger math nerds than I am, but geeks galore. All right. Well, thanks everybody. See you next time. Bye.